Welcome to Shiny Grades Online School. Today I'll be taking you through Metals Form 4, Series 2, Extraction of Sodium. Please don't forget to like, comment, and subscribe to our YouTube channel. Welcome. Looking at the extraction process of sodium metal, let's start by looking at the occurrence of this particular metal. So metal, sodium, occurs as dissolved chloride in seawater, meaning it is found in form of dissolved sodium chloride, or what we call aqueous sodium chloride. The same metal can also be found as a double salt, or what we call toner, Toner is a double salt of sodium hydrogen carbonate, with two water molecules, So that is a toner. Why a double salt? Because of the presence of two anions, hydrogen carbonate ion and the normal carbonate. So this qualifies it to be a double salt. It can also be obtained as saltpeter. It can also be obtained from saltpeter. Saltpeter is another ore to sodium metal. Saltpeter is solid sodium nitrate, and is commonly found in Chile. And that's the reason you'll find sometimes we call it Chile saltpeter. We also call it Chile saltpeter. And lastly, the other ore to sodium metal is what we called the rock salt, which is the chief ore to sodium metal. And this particular salt is solid sodium chloride, which is the chief ore to sodium metal. Let's now look at the process of extraction of sodium metal. Sodium metal is extracted by the Downs process. Why the Downs process? It involves use of the Downs cell. And why the Downs? This particular cell and process was named after scientist known as James Cloud Downs. And this scientist was the first person to invent the process of obtaining sodium metal through the process of electrolysis, and that's the reason the process was referred to as Downs process, and the cell that is used in the process as the Downs cell. Looking at the materials that are used during the process of electrolyzing molten sodium chloride, through this particular entrance, molten sodium chloride. When you say molten, we mean sodium chloride is molten in form of a liquid. It has been melted in a molten state. It is fed through this particular entrance into the down cell. Through this particular entrance, it's actually an exit where a gas formed in the process of electrolyzing sodium chloride exits the system. On the other side, we have molten sodium. Sodium, now in form of a liquid, is collected to specific containers or chambers, and that's the end product of this whole process. But when you look at the system so well, you will notice presence of calcium chloride. Calcium chloride is added to molten sodium chloride purposely to lower the melting point, of sodium chloride. Learners, sodium chloride is an ionic compound with a very high melting point. There's a very high melting point of around 800 degrees Celsius. And calcium chloride is added to that particular molten sodium chloride, and the melting point is lowered to 600 degrees Celsius. So we can see the melting point of sodium chloride being lowered from 800 degrees Celsius to 600 degrees Celsius, and this process makes the whole process of electrolyzing and obtaining or extracting sodium very economical. If this is not done, then a lot of electricity is used in the whole process, and therefore adding calcium chloride makes the whole process economical. Learners, when you take note of the display of the picture of this down cell, you will notice that in this particular cell, we must have the negative charge and the positive charge, what we call the positive terminal and the negative terminal. In our case, in the down cell, steel is used as the cathode. In this case, cathode is the negative terminal, and in this case, steel is used as the cathode. When you observe it, you will also see it. It is on the left and on the right side of the cell. So we can also see cathode on this particular side, which is made of steel. You will also notice carbon being used as the anode. The anode, which is the positively charged terminal, the cathode. And in our case, carbon is used as the cathode, as the anode. Carbon is used as the anode. When you take a good look, you will also notice plates which are found in between the two terminals, the positive and the negative, so that the products of the process, they do not mix during the process. So in this case, we also use a steel diaphragm. This is steel. It is placed in between the two terminals, the positive and the negative terminal, and this prevents sodium and chlorine from recombining once again. Remember, those are the end products of the process, chlorine and sodium in molten state, which is the final product when sodium chloride is electrolyzed. So sodium will be formed at this chamber here, and then we have chlorine being formed here. So if there was no this particular steel diaphragm, then the two shall recombine, and therefore we will not be able to collect our sodium metal. The down cell consists of an ion shell with its bricks on the outside, purposely to maintain high temperatures so that the electrolyte does not crystallize. Remember, sodium chloride should be electrolyzed when in molten state, so high temperatures should be maintained within the chambers of the down cell to ensure the electrolyte remains in molten state throughout the process of electrolysis. Again, on the structure of the down cell, we had already talked about the anode and the cathode. So at the center of the cell, we said carbon anode acts as the positive terminal. And then we have steel cathode, which acts as the negative terminal. We have also talked about the addition of calcium chloride to sodium chloride, which is done to lower the melting point of sodium chloride from about 800 degrees Celsius to 600 degrees Celsius. And this makes the process economical and saves on electricity used in heating. Learners, during the electrolysis process, sodium metal is formed at the cathode, while chlorine gas is formed at the anode. And this is represented by the ionic equations below. Remember, initially we had sodium chloride, which is our electrolyte. When electric current passes through that particular molten solution, it ionizes to produce sodium ions and chlorine or chloride ions. At the anode, chloride ions loses electrons to form chlorine gas with the release of one electron, which we balance with 2 to balance the atom of chlorine. On the other side, that is at the cathode, sodium ions gains an electron to form sodium metal, which is produced in liquid form. And because 2 electrons were lost, we also have to gain 2 electrons in the case of sodium metal. Let's now look at the diagram and try to see this is the down cell, And we have seen at the anode, which is represented by the carbon anode, we have talked about at the anode, the chloride ions lose electrons to form chlorine gas with the release of one electron, which we balance with a 2 to be 2 electrons. So chlorine gas is formed at this particular point. This is where chlorine gas is formed, and once formed, it is released onto the atmosphere. But remember, this particular gas is very poisonous, and it cannot be allowed to the atmosphere because of its toxic or poisonous nature. So chlorine gas is subjected, it is one collected into containers or kept to be used as a raw material in most industrial processes. And one of these processes, we have manufacture of hydrochloric acid, we have manufacture of plastics, we have manufacture of solvents, and also disinfectants. So chlorine cannot be released into the atmosphere simply because it is a poisonous gas, and again, it is a raw material in most of industrial processes. So those are two reasons as to why chlorine gas is not released. One, it is a raw material in most of our industrial processes, and again, it is a poisonous gas. Moving to the cathode, sodium ions, they move to the cathode and they gain electrons. They gain an electron to form sodium metal in form of a liquid, which is collected into specific tanks through this particular pipe or tube. And we had lost 2 electrons. We also have to balance sodium ions and electrons with 2 to make them 2 electrons. So that is how sodium metal is formed. That is how sodium metal is produced together with chlorine, which is also subjected to other uses. Let's now look at the description or the explanation. We talked about a steel diaphragm, which is suspended between the electrodes to prevent sodium and chlorine from recombining. So we can see the presence of steel diaphragms here, which ensures that the cathode is separated from the anode. That ensures that the end products of electrolysis, that is chlorine and sodium, do not recombine. This is because these two are very reactive. They react too fast. So there is need of separating the two to ensure that they do not recombine. Moving forward, molten sodium is less dense than molten sodium chloride. So we already have formed sodium, and remember the sodium is coming from the sodium chloride. How do we get to collect our sodium? So sodium, being less dense than molten sodium chloride, it rises to the top of the cathode, and it is easily or periodically removed from that chamber and collected into the specific containers or tanks. So that is what makes sodium to be easily separated. It is less dense than sodium chloride, and therefore it is periodically removed. It is able to float. It is able to rise on top of the cathode, and then it is periodically removed. So if somebody asks why is it possible to collect sodium from sodium chloride in the electrolysis process in the down cell, it's because sodium metal is less dense than sodium chloride, and therefore it's able to rise on top of cathode where it is periodically removed. So chlorine gas, as we have said, is not allowed into the atmosphere because it is a poisonous gas. And we have also said that instead it can be subjected to other uses. It can be, chlorine is used as a raw material in most of industrial processes, and we have said that it can be used in manufacture of hydrochloric acid, manufacture of solvents, manufacture of plastics, and also in manufacture of disinfectants. So chlorine, apart from being a poisonous gas, it is also a raw material in most of industrial processes. We also notice that liquid calcium metal may not be produced at the cathode. But why? Why is it that during the formation of sodium, calcium is not also formed at the cathode? We notice that this particular metal can still be produced at that particular terminal. However, calcium liquid do not mix with sodium liquid. This is because it is much denser than sodium metal, and that makes calcium to remain at the bottom as sodium floats on top of this mixture. So calcium, again, apart from being more denser, it also has a higher melting point compared to sodium. So during the cooling, calcium will be able to crystallize fast, leaving liquid sodium in molten or in liquid state, which is then trapped. So main reasons as to why calcium is not also produced or collected is because it's much denser than sodium, molten sodium, and therefore settles at the bottom. And again, it has a higher melting point compared to liquid sodium. Therefore, it is able to crystallize fast compared to sodium, and therefore sodium is trapped out before calcium or instead of calcium. Let's now, learners, move to the uses of this metal, because anytime we extract a metal, we extract that metal with an aim of using that metal in various activities or in various subjected to various uses. So why do we have to extract sodium? Uses of sodium. So one of the uses of sodium, it is used in manufacture of compounds such as sodium cyanide. Sodium cyanide and sodium peroxide, and they are used. The sodium cyanide, it is used in extraction of gold, and you also see sodium peroxide being used as a solvent in chemical processes. Another use of sodium metal. It is used in manufacture of sodium hydroxide, which is used in the manufacture of detergents, paper, glass, and even artificial silk. So that's another use of sodium metal. Manufacture of sodium hydroxide that is used in manufacture of detergents, paper, glass, and even artificial silk. Another use to sodium metal. Sodium cyanide is used in extraction of gold. Sodium cyanide is used in extraction of gold. Remember, sodium cyanide is a compound of sodium. We also have sodium is used as a reducing agent in some reactions, such as reduction of titanium 4 chloride to form titanium metal. So sodium is used, in other words, sodium is used in extraction of titanium from titanium 4 chloride. So that's another use of sodium metal. Another use of sodium metal, sodium vapor is used in street lights, which gives yellow orange light. So most of the street lights that we see that are yellow in color, they use sodium vapor. So they are used in street lights or lamps, which gives yellow orange light. So learners, let's not commit ourselves and say sodium is used in manufacture of street lamps. It is used in street lamps, which gives yellow orange light. Another use of sodium metal, sodium is used in making an alloy of sodium and potassium, which is used as a coolant in nuclear reactions or reactors, because the alloy is a liquid of a wide range of temperatures. So the alloy of sodium and potassium is used as a coolant in nuclear reactors, simply because that particular alloy, it behaves or it remains in liquid state over a very large range of temperatures. And lastly, learners, an alloy of sodium with lead is used in the manufacture of tetraethyl lead, which is used as an anti-knock additive in petrol. So this has been discontinued as use of leaded fuel has been phased out. So learners, we have all heard of leaded petroleum, or what we call leaded fuel. So initially, some time back, tetraethyl lead was added to this particular petrol to act as an anti-knock, to prevent knocking of the engine. And because lead is a heavy metal, it's a poisonous metal, a toxic metal, that activity of adding tetraethyl lead has been discontinued because of the property of lead of being an heavy metal. So learners, it had been used some time back, that is in manufacture of tetraethyl lead, but it has been continued due to the toxic nature of lead. That's the reason when you go to some petrol stations, you realize that we have unleaded petrol, meaning it was initially there and they stopped, so it is now unleaded. Does not have the lead that used to be added to petrol. So learners, this marks the end of our presentation. Please don't forget to like, comment, and subscribe to our YouTube channel. Thank you very much for watching. God bless you.